Namaste everyone. In this video we are taking up a problem on kinematics of machines from Osmania University paper. This paper came in December 2017, you can see over here, and we'll be covering a problem on cams in this particular video. So if you are new to the channel, make sure you like the video and subscribe to it for further such videos. So without much ado, let's begin. So here I have copy pasted this particular question into AutoCAD, and of course I'll be using AutoCAD to solve this problem, of course explaining the use of different instruments as we go by. If you want, you can just pause the video and take a look at the question. Okay, so here I have noted down all the given values from the question I have noted here, and we are just supposed to draw the cam profile. So let's begin. So the first step, of course, is to draw the base circle, and we know here that the base circle radius has been given as 45 mm. So let's take a circle of 45. Okay, that's a bit big. So we need to just get an idea about how big the circle is going to be, and how big the cam is going to turn out to be, and we have to adjust its size on the paper so that it's going to be appearing within the limits of whatever page size we have. So because the radius here is 45, the diameter is going to be 9 centimeters, and further there is a rise of 30 mm, so that adds 30 mm on one side, so 90 plus 30, the overall size is going to be around 120 mm, that is 12 centimeters. So on the sheet we have to adjust the size and make sure that 12 centimeter of size on both the sides are to be available. That's the precaution we have to take in exams. Okay, so the next thing we have to do is from the center of the circle we have to take a vertical line. Okay, and from this vertical line we have to take an offset, and the offset has been given as 15 mm. So take an offset of 15 mm. Let's take it towards the right, and we need to draw a circle, and this circle can be called as the tangent circle. And after dividing the angle of rise into a number of parts, we have to draw tangents to the circle, and those tangents are the points from where we have to take the offset of our roller. Okay, so now that we have the tangent circle and the base circle, the next thing we have to do is the prime circle. So prime circle is a circle which passes through the tracing point, the center point of the roller, when the roller is touching the base circle. So for that we'll have to take an offset here in AutoCAD. So 15 mm, sorry, not 15 mm, the diameter of the roller has been given as 20 mm. So the radius is going to be 20, sorry, radius will be half of the diameter, that means 10. So let's take an offset of 10 mm from the base circle, and the intersection of this axis and the prime circle, that's going to give us the roller circle. So roller circle radius is 10, and when I draw this, you can see that the circle is actually touching our base circle. So now we have the initial position of our roller, and from this position we need to start making the divisions. Fine, so this is the line from where we'll have to measure the angle of rise. So let's begin. So angle of rise has been given as 120. So here you need to place your protractor like this, and got to take that angle of 120. That's over here. The next angle that we want is dwell angle, and that dwell angle is for 60 degrees. So let me rotate it to 120 degrees, and from this line we need an angle of 60 degrees. Okay, and from there we need another angle of 90 degrees. So let me take another 90 degrees from here, and for whatever angle remains, that angle will continue to be dwell period. Fine, so for between these two lines it will rise, between these two lines it will remain at dwell, and between these two lines it will come back, it will return to its initial position. Okay, so the next step for us is to divide this 120 degrees into equal number of parts. So how many parts are we going to take? We're going to take 6 parts, and 120 by 6 will provide us with 20. So at gaps of 20 we need to take this divisions. At gaps of 20 we need to take the divisions. Okay, that's 90 next. After 90, oh sorry, that's going to be 80. So this is not going to be 90, this has to be 80. And then after 80, of course, there is the 100. So let's move aside this protractor. And you can see we got 6 equal divisions over here. So let us extend this right up to this point. Fine. So we need the intersection of this with either the prime circle or the base circle. Any one of them is going to be okay. And the next thing we have to do is to draw tangents from these points that we got in the prime circle. So each point of the prime circle we need to take and we need to draw tangent to the circle. Tangent to the circle. Fine. Now on these tangential lines, this is where we need to take the displacement. Fine. And for us to take the displacement, we actually need to have the displacement diagram first. And let us go ahead and draw the displacement diagram. The total rise has been given as 30 mm. So we need to draw a vertical line of 30 mm. Horizontal line, of course, we are going to just take as 60 for our convenience. Let's give a gap of 20 mm and then further let's take 60 one more time. Now let's complete this rectangle and then let me copy this to the endpoints. So this rectangle we're going to use for rise and this one we'll be using for lowering. In fact, because both rise and return are happening with the same kind of motion, we actually don't need to draw them separately. Whatever we draw in the first, the same we can continue to use it for both the cases. Okay, so let's divide this circle again into 6 equal parts. So, and of course we need to divide this line as well into 6 parts. So we just get 10 mm of offset. Let me continue to take it, and the same I need to do it over there. So let me just copy them. Right. So now that we have the 6 centimeters divided into 6 parts over there, we need to start rising the part. So this is where the first point comes in, then comes the second, then the middle one, then the next, and then to here. Fine. So this will be the spline. So smooth curve, we need to join all these points, and the same curve, in fact a mirror image of this curve, we're going to get on the other side. So we can either just extend this line, the other side, extend these lines to the other side. Right. That's so that gives us the points on the other side. These points again we need to join with the smooth curve, and that's it. This gives us the displacement diagram. And now using this displacement diagram, we need to we need to transfer these displacements over here. Fine. So now these displacements we need to mark from the prime circle and not from the base circle. Fine. And of course tangent circle is not in question at all. So it is from here that we need to mark all the points. So I have taken that distance. Now because the radius of the circle is going to be same on all the sides, from the center any point on the circumference is going to measure the same, and we have taken that measurement from here. So let me extend this line, and this is the point where the follower center, the center of the follower will be after rotating this angle of 20 degrees. The next, let's take after the rotation of 40 degrees, that will appear here on the second line, and yeah, the end point is going to be here. Let's continue doing this. You can fast forward this if you're aware of this and go to part that you are not aware of. Okay, so we have now got all the positions of the ruler. We now got all the positions of the ruler. Then we just need to copy the ruler to all these points. Fine. And our cam profile has to be tangential to this. And our cam profile needs to be tangential to all the circles. So it should pass through all the circles like as if it is touching them. Fine. So let's go ahead and draw that. Actually, we can just draw this curve, the curve passing through the centers of the rulers. This curve is going to be called as the tracing curve, and we could go ahead and take offset of 10 from this in AutoCAD, and that will give us the tangential curve. Fine. Of course, when you're drawing it manually, then you may have to use your instrument and knowledge about geometry to achieve this. So the cam profile is what we need to make it dark. Fine. So this is the starting position of our roller, and this is the cam profile. Okay. Next, from here, it needs to remain at the same position for this total angle. Fine. So let us take the angle here. So this needs to be tangential. Okay. And now we need to take the same displacement that we have here to this point. Okay. So between these 2 points, it has to remain at the same place. Okay. Between these two, it has to remain at the same place. Okay. So the cam profile after this is going to look somewhat like this. Okay. Of course, this needs to go away too. Okay. And of course, the trace circle is going to pass through like this. Trace curve actually is going to be like this. So this one here is the trace curve, and what we get here, the dark one, is the cam profile. Now from this point forwards, it has to return, and the return also has to be with SHM, but the angle here, that is different. Fine. So we have an angle of 90 degrees. So we again need to divide the angle into 6 equal parts. So let's take 90 degrees divided by 6. That gives us 15. So let's take our protractor, keep it at the right position, and from here we need to divide it by 15 degrees each. So 15, and then comes 30, and the next angles will be 45. From 45 we have to take 60, and then 75 to 90. Fine. So these are our lines. We need to extend these lines up to here. Okay. And these are the lines on which we have to lower our cam slowly. So once again, we'll have to take this displacement on the, okay, before that we still need to draw the tangents from all these points. Okay, once all the tangents are drawn, this is the next position, and the ruler has to be at this center point. Okay, let's go ahead and take the next. So as I told, you need not draw 2 separate displacement diagrams, one for return and one for rise. If you draw a single diagram, you can just continue to take it in the reverse direction. Fine. So this point we are done taking. The next point is going to be here, and you can just go ahead and take it. Okay, so this is our next one is going to be here. So it doesn't matter on which diagram you're going to take, whether you take it on the rise or the return, it's going to be the same. So we could just go ahead and do that the same way. Okay, so now we got all the points. Now we need to take the circle, the roller, and keep the roller at all these points. And once again, I'll take a spline passing through all the center points, so the tracing points you can say, and tangential we just need to keep it tangential like that. And then because this is a trace curve, and of course I just need to take an offset of 10 to get the cam profile. Fine. So when you're doing it manually, you just need to try it very carefully, and that's what you need to do. So the remaining part, let me make it drop over here. Yeah, so this dark curve that we got here is the cam profile, and this curve that I've drawn in dashed long dash, small dash kind of thing, the phantom color, that is our pitch curve. This circle that we have is a prime circle, and this circle that we have here is our base circle. This of course is the tangent circle meant for the offset of the follower. So that's it. We have not been asked to find maximum velocity or acceleration in this one. If you're asked, you can just go ahead and use the formula for maximum velocity, maximum acceleration. If you want you to find the velocity at any particular point, you can just do that as well. If you know the formula, just substitute the value of theta and you'll be able to calculate that. So thank you for watching this video. For more such videos, of course, don't forget to subscribe to the channel. Thank you.